In their classic 1977 work on zero-phase wavelets, Calwait and Wood showed that high-frequency side lobes can be suppressed by applying a gentle 2-octave high-side slope. But what is the cost associated with suppressing the side lobes? Is there a trade-off between side lobes and resolution? If yes, then how much resolution is lost? Their conclusion was that given 2 octaves or greater bandwidth to work with over a given low pass, the temporal resolution of a 2-octave F3, F4 wavelet equals 80% of the temporal resolution of a sync wavelet with an equivalent F4. In other words, given a consistent upper frequency of usable signal, we lose 20% of the resolving power when we apply a 2-octave high-end slope. Here, we see a simple one-layer wedge model in its unfiltered raw form. 0 thickness on the left and 30 millisecond thickness on the right. With no filter applied, the peaks and troughs represent true spike positions. This relationship can be charted as peak to trough separation on one axis versus true spike separation on the other axis. If we then filter the reflectivity using a low-pass 64 Hz F upper sync, we introduce tuning and severe side lobes. The peak to trough separation no longer follows true spike separation. It is tuned by the interaction of the filter design with the underlying reflectivity. The temporal resolution, labeled TR, is defined by the thickness below which the peak to trough separation is no longer sensitive to the true spike separation. If we were then to simply apply a 2-octave high-side slope to the existing bandwidth, we would suppress the side lobes, but at the cost of 20% of the resolution. To preserve the resolution that we saw in the sync case, we have to not only apply the 2-octave high-side slope, we also need to increase F upper from 64 Hz to 80 Hz. Tuning is still present, but the side lobes are now suppressed, and resolution, TR, in both cases is now the same, but with side lobes suppressed. Can the benefits associated with attenuating high-frequency side lobes outweigh the 20% loss in temporal resolution? In many cases, yes, but not always, particularly if that 20% loss is critical to the imaging of your target zone.